All right, welcome to lecture 27, part B. So in the last part, we talked about what the heck a solution is. We did a little vocabulary with solutions. Now, in this part, we're going to actually do a little calculations. So have a calculator handy. We're going to do a little math. And really the goal for this part, we're going to learn to determine the concentration of a solution. What does that mean? Well, you're about to find out. All right, so we know what a solution is now, right? Two things mixed together, a homogeneous mixture of two or more things. Now, what we're going to talk about in this part is that for a lab to work or for things to go the way you want in an experiment, often you need to have a solution at just the right concentration. If it's not concentrated enough, maybe it won't, the experiment won't work. Or maybe if a solution is too concentrated, it could even be like a dangerous solution. So what we're going to talk about in this part is how do we measure the concentration of a solution? So the way we measure the concentration of a solution, it involves our favorite unit, which is moles. So specifically, we're going to tend to talk about how concentrated a solution is using molarity. Molarity is just how many moles of stuff, so moles of solute, did you dissolve in every liter of water, So molarity is how many moles of stuff are in each liter of water. Now, molarity, often we just use the shorthand for it. The symbol for molarity is a capital M. All right, let's do a little example. All right, let's say I'm going to make up a solution, and kind of the most common solution is probably just making up some salt water. So I mix, let's say I mix 18 moles of salt, and I place 18 moles of salt in 3 liters of water. And I want to know what's the concentration, what's the molarity of this solution. All right, so the way you figure it out, our equation, molarity is moles divided by liters, moles divided by liters. All right, so if you work it out, I told you, hey man, we're going to get 18 moles of stuff. That's the stuff you're dissolving is the solute. 18 moles of salt in this case. And you divide it by the volume of water, which is 3 liters. And if you work it out, what you'd come up with an answer 18 divided by 3. Oh, I could even do that in my head. It's going to be 6. All right. Now, for sig figs, I'd actually call it 6.0. And, there's got to be a unit on there, 6.0, and then the unit would be molarity, capital M. All right. So capital M, that's our unit. That's molarity. That's our unit of concentration that we're going to deal with. Now, the only other thing I want to talk about or mention to you is that capital M, that stands for molarity. Sometimes people might just write it out. In other words, you might see the answer written this way, 6 moles per liter. That totally works. It means the same thing as capital M. Or you might even hear it when people say it, they'll say it's a 6 molar solution. So that's like the way we tend to say it. Capital M, we say molar. All right, so all those mean the same thing. All right, with that, let's just double check this is making sense. Tell me the concentration of a solution. Tell me the molarity of a solution. All right, I'm going to flip over. Let's see if you could try one here. All right. What is the molarity of a KNO3? So I guess that's what, potassium nitrate? What's the molarity of a potassium nitrate solution containing 2.5 moles of potassium nitrate and 500 milliliters of solution? So, okay, I want to give you a little hint on this, and I'm going to let you think about it. So potassium nitrate, that's a solid. They've dissolved 2.45 moles of that solid in 500 milliliters of water. That's what they're telling you. Now, what's the formula for molarity again? It's moles of stuff divided by how much water you used, how many liters of water you used. All right, I'm going to give you one more hint. Okay, try to figure it out. Oh, the right answer, it should have been E. Should have been E. Did you get E? I hope you got E. Let's double check. All right, so the moles of stuff, we use 2.45 moles of potassium nitrate as the stuff this time, divided by, not milliliters of water, divided by liters of water. So what you had to do is you had to convert the 500 milliliters to liters. Oh, I hope you remember to do that. All right, so it's not per milliliter. You got to have liters on the bottom. So I gave you the conversion factor here. Oh, so how are we going to make that work? If you have milliliters, milliliters goes on the bottom. To cancel, that means the 1,000 goes on the bottom and the 1 liter goes on top. So the volume of water, it should have been 0.5 liters. And that's what you're going to put into your equation, 0.5 liters. Now, oops, should have been another zero there. Trying to be good with my sig figs. So if you work it out, the right answer, yeah, if you divide 2.45 divided by 0.5 liters, yeah, it works out to be 4.9. So yeah, that should have matched up with number E. All right, so with that, we're going to move on. Now, so far we've learned this big important equation. Molarity is moles divided by liters. Now, life can get a little trickier. I can be a little meaner to you. I was already a little mean to you in this one, right? Because I gave you the volume of the water in milliliters, and you had to convert it to liters. But the way life can get a little bit tougher is often I'm not going to say you use 2 moles of this stuff. I'm not going to say you use 20 moles of this stuff. You're going to know the weight of the solid in grams. And so that's actually a little bit more realistic, right? That you would know how many grams of stuff you're putting in the water. And then you want to figure out, well, once that gets into the water, those 20 grams or 50 grams of whatever, what's the molarity? All right, so let's do another problem where instead of being nice to you and telling you how many moles you're using, what if I was to tell you how many grams you're using? All right, so let's flip over and we'll do an example like that. Okay, so in this example, I'm a little meaner to you. Okay, I'm just going to be just a little meaner to you. So it says if you dissolve 75.0 grams of NaCl, salt, in 250 milliliters of water, what's the concentration of the solution? So how concentrated is the solution? So when I say concentration, really what I'm saying is molarity. I want to know what's the molarity of this solution. Now let me remind you, we just learned the formula for molarity, didn't we? Molarity is moles divided by liters. Moles divided by liters. All right. Now, if you look at what I gave you, I didn't really give you either one of those numbers. I didn't give you moles, I didn't give you liters. So what we're going to have to do to figure out the molarity of this solution is, well, I'm going to have to take the grams. The grams, I told you, 75 grams of salt, and I'm going to need to convert it to moles. Now, grams to moles, oh, we did that before, periodic table. And then I didn't give you liters either. So what you're going to have to do to get liters, you're going to have to convert the milliliters to liters. The milliliters to liters, the 250 milliliters. So the conversion there, I think we used that in the previous part. 1,000 milliliters is 1 liter. All right. So if you don't have moles and you don't have liters, well, you got to get those before you can try to find molarity. All right. Let's see if we can work it out. So 75 grams of salt. I got to know how many moles that is of salt. So to do that, I'm going to add up the weights off the periodic table. Oh, we've done this before. 1 sodium, 1 chlorine. Sodium, 22.99. Chlorine, 35.45. Right there. If you add it together, oh, just one of each, the grand total works out to be, that should be a 9, 58.44. 58.44. Oh, that's always a conversion factor. 58.44 grams equals a mole. There's your conversion factor. All right, so with that in our head, let's see what we need to do. 75 grams of salt. If I want to know how many moles of salt that is, you put grams on the bottom. That makes the 58 go on the bottom. And then we'll put the 1 mole on top. 1 mole on top. Should look like that. All right. Is that going to work? Oh, yeah, I think so. Grams will cancel. That's what we wanted. We want to have moles. So if you work it out, when I did this earlier, I got 1.28. So we've used 1.28 moles. All right, that's good. We need moles to find molarity, but we also need liters. So we're going to have to take the milliliters and convert to liters. Let's do that. 250 milliliters of water. How many liters is that? So in the middle here, we'll put our conversion factor. Well, it's up here already. Should I rewrite it? Oh, I don't know if I will. We'll just see it here. 1,000 milliliters is a liter, right? So if you have milliliters, 250 milliliters, you would have to put the 1,000 on the bottom and the 1 liter on top. So if you divide by 1,000, the amount of water we're using 0.25 liters, 0.25 liters. All right, so now we're in business. Now we're in business. We have moles, we got liters. If we divide those two, we'll get our molarity. All right, so that's what I need now. So let me go ahead and work it out down here. Molarity is just moles divided by liters. 1.28 moles of salt divided by 0.25 liters of water. If you work it out, what I came up with earlier, we would have made a 5.1 molar solution. So molar, you can write capital M, or if you want, you could write 5.1 moles per liter. That would be the concentration. All right, so let's just make sure this makes sense. I hope it does. So you get out a beaker, and in this beaker, you toss in 75 grams of salt. You also toss in 250 milliliters of water. When you put it together, the concentration of that solution, once you've put it all together, you're going to have a solution that's 5.1 molar. That'll be its concentration. All right, let's try another one. Let's try one more in this video. Let's see. Let's try one more just to make sure this is making sense. All right, let me flip over one more example here. All right, one more example on these same lines. One more of these examples. All right, if you place 84.5 grams of nickel 2 nitrate and 345 milliliters of water, what's the molarity? If you place 84.5 grams of nickel 2 nitrate and 345 milliliters of water, what will be the molarity of this solution? All right, so we're trying to figure out the same thing as before, right? Molarity. So molarity is moles over liters. So we're going to need to know moles, we're going to need to know liters, we're going to have to divide. Now, in this case, we're starting off with nickel 2 nitrate. Now, nickel 2 nitrate, it's a solid. So, you know, when you buy chemicals, they just mail you a little box of a solid. So this is the box that's got nickel 2 nitrate in it. All right, and let's say I was to take 84.5 grams out of this container. All right, there it is. And I'm going to stick it in 345 milliliters of water. I want to know the molarity when the two get together. All right, so that means we need to know the volume of water in liters. Well, we can do that. We've got milliliters. We got to go to liters. And then we're also going to have to know the amount of nickel 2 nitrate, not in grams, but in moles. So to do that, we're going to have to go from grams to moles. We're going to have to bust out our periodic table again, aren't we? 84 grams. How many moles is that? Now, the way you go from grams to moles again, you add up the weights off the periodic table. Now, this time I'm even a little meaner to you than last time because I didn't tell you the formula. What atoms are we supposed to be adding up to get that conversion factor from grams to moles? Well, the way you're going to know, you're going to have to figure out the formula. Nickel, what's the symbol for nickel? Ni. What does that Roman numeral mean? Oh, that means the charge. Nitrate. What's nitrate? Oh, that's a polyatomic. It's NO3 minus 1. So when you put them together, the right formula, it should be NiNO3 2. So we're going to need to add up those atoms off the periodic table. That's your conversion factor. So you got to know the formula, right? So you need to figure that out. Get those charges to balance and everything. So adding up 1 nickel. Where's nickel? Right here. You're going to add up how many nitrogens? Oh, you got to like multiply 2 nitrogens. And then you're going to add up 6 oxygens. All right, I'm going to give you a chance to practice this just to make sure you can do this. We haven't done this in a while. What's the, I guess this is called the molar mass. What's the molar mass of nickel 2 nitrate? Oh, it should be about 182. 182, what did I get? 182.71. Did you get that? All right, let's double check. 1 nickel, 58.69. 2 nitrogens, 6 oxygens, 58.69, 28.02, and then 6 times 16 is 96. If you add it up, the grand total, oop, I kind of ran out of room there. I'll put it over here. 182.71. That's what I got. 182.71. Oh, there's your conversion factor. 182.71 grams is a mole. All right. We're trying to go from grams to moles. What do you do with the 182? Multiply or divide by it? Oh, you should have divided. You'll put the 182 on the bottom. You put the 1 mole on top. When you work it out, we have used 0.462 moles of this nickel nitrate, nickel 2 nitrate. All right, great. We got moles. Beautiful. We need that. We need that. We also need liters, liters of water. So the amount of water, the liters of water, well, we'll have to take milliliters and convert to liters. Now, you might remember I mentioned a minute ago in the previous example, the way you go from milliliters to liters, 1,000 milliliters is 1 liter. So milliliters to liters, divide by 1,000. That should do it. And if you work it out, you get 0.345. All right, I think we're in business now. Molarity, it's not grams and it's not milliliters, it's moles divided by liters. So we have those two numbers now. Kind of ran out of a little room. Let me erase this and we'll finish it right here. Moles, 0.462 moles divided by liters, 0.345. If you work it out and you round it and you do all that important stuff, you get 1.34 molar. 1.34. All right, so if you mix 84 grams out of this box of nickel nitrate with 345 milliliters of water, that's about the size of a soda can, a regular can of Coke or Pepsi. If you put the two together, you're going to get a solution that's just a little over 1 molar, 1.34 molar to be exact. All right, so that's it for this kind of calculation. There's one more part to this video, and we'll move on to that. We're going to do one more type of math problem in this lecture with molarity. Let me stop this one, and we'll move on to part C.